Hello again. This is the second video for section 3.6. Just going to do some examples that you'll see something similar to in the homework. So looking at this top picture, you have two lines that are perpendicular to each other. You also have two angles that are adjacent to each other. So if two angles are adjacent to each other and the sides of those angles form a right angle, these two angles are going to be complementary to each other. It's one of the theorems that you copied down from the first video. So x minus 15 plus x plus 5 will equal 90 degrees. And so we combine like terms. We get 2x minus 10 equals 90. 2x equals 100. By adding 10 to both sides, we get x equals 50. Now, I didn't really put a question on this. So the question may be solve for x. It may be figure out the angle measurements, in which case, if it was, what are the angle measurements equal to? 50 plus, looking at this bottom angle here, x plus 5. If x is 50, this angle is 55 degrees. 50 minus 15, 35 degrees. Okay, so just pay attention to the question. Make sure you're answering the actual question. All right, for the middle example here, we have this perpendicular marker here. This whole thing, it's not a linear pair, but all three angles are supplementary to each other. So if this is 90, that means this has got to be 90 as well. Let me clean that up a little bit. If this angle here is a 90-degree angle, right angle, those two are going to be a 90-degree angle also, which makes these, again, they're adjacent angles. The sides are forming a right angle. These two are going to be complementary to each other. So add them up, 51 plus 2x minus the 11, that equals 90. And it is very similar to the first example that we just did. So combine some like terms. We get 2x plus 40 equals 90. Subtract 40 from both sides. Divide by 2. We get x is 25. And same thing, we could figure out the other angle measurement depending on what the question is asking for. All right, for this bottom example, you're given a whole bunch of stuff. Question is, what do all six unknown angles equal? So, I'm going to start right there with that perpendicular. When these two lines cross and there's one right angle, makes four right angles. So if this is 60 degrees here, angle 2 has to be 30 degrees. So measure of angle 2 equals 30 degrees. All right. Now, angle 2 and angle 4 are vertical angles. So that's also 30 degrees. Measure of angle 4, also 30. We have, I'm going to try to change colors here. Again, perpendicular there. So if angle 4 is 30 degrees, angle 3 has to be 60 degrees. And we could have done vertical angles here with the angle 3 and the 60 degrees that we were given. Now, with angle 3 being 60 degrees, and change colors one more time, and that being a 90-degree angle that you were given, with that being 60, angle 5 has to be 30. And what do we have left? Angle 1, you're given that. That's 90 degrees, the right angle notation. All we're left with is angle 6. So I'm going to clean this picture up here a little bit, some of it. These main two lines, the horizontal and vertical one. There was a right angle here, which means there's going to be four right angles. So if this part is 30, angle 6 has to be the remaining 60 degrees. And that is angles 1, 2, 3, 4, 5, 6. We got them all. Okay. All right. For this next and last one, find the distance from point A to line C. When you measure distance, you got to go perpendicular to the object. So we're going to go from point A perpendicular to line C. Now, to find distance, you need to have 2 points. or at least it's very helpful to have 2 points. Usually you need that. Sometimes there's other information that you may be able to avoid having the 2 points, but that's not in this case here. So what we need to do, we need to make sure that we're going from A perpendicular to line C. To make sure we're going to be perpendicular, we need to start finding some slopes. So we're going to find the slope of line C. So we're going from this point up here, we're going up 1, 2, 3, 4, 5, 6. So the rise is 6. The run, we are going over 1, 2. We got a slope of 3. Now, we need to be perpendicular from A perpendicular to C. Okay, the slope of the perpendicular line, and that's this notation here. The slope of the perpendicular line is going to be the opposite reciprocal of 3. That's a negative 1/3. So what we're going to do is go from point A, use that slope of negative 1/3, and go to line C. That's going to make us go perpendicular from A to line C. So from A, I'm going to go down 1 over positive 3. That puts me right here. That's perpendicular there. By using the slopes, we're guaranteeing that we're going perpendicular because that's how you got to measure distances. So point A is at the coordinate 0, 2. We'll call this point point B, where the perpendicular from A hits line C. Point B, it is at the coordinates 3, 1. Okay, just using the grid, it was right there at that point. Using the idea of slope, put us right at that point 3, 1. So now we need to find the distance. Okay, again, measure distance perpendicular from an object to another, from point A perpendicular to line C. So we're literally looking for the distance of that segment AB. Distance formula: giant square root, difference in the x values, quantity squared, plus difference in the y values, quantity squared. And order of operations says do all the stuff inside first. So 3 minus 0 is 3. We're still squaring that. 1 minus 2 is a negative 1. We're going to be squaring that. 3 squared is 9. A negative 1 squared is 1. We add those up. We get square root of 10. That is the exact answer. Make sure you read the question carefully in the homework on quizzes or tests. Sometimes it might say round your decimal, or round your answer to the nearest tenth or hundredth. Square root of 10 is 3 point something. I'm not sure what it is. 3.3, 3.4, somewhere in there. Okay, but square root of 10 is the best answer. All right, that is it for the example video. I'll see you in class tomorrow. Have a good day.